In this video, I will introduce combinational circuit and the design procedure of this circuit. Combinational circuit is a digital circuit whose output will depend upon the input variables. As the name indicates, the output of a combinational circuit will depend upon the combination of the input variable.
Characteristics. The output at any instant of time depend upon the input present at that instant of time only. That means the output of a combinational circuit depends upon the present input. Next, it do not use any memory. That's mean it do not store any previous state. Output depends on the present input only. It can have n number of inputs and m number of outputs. Look at the diagram. I have written or labeling the input as 1, 2, 3, dot, 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 n, and in the output, the right hand side, 1, 2, 3, dot, 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 m. So a combinational circuit may have n number of inputs and m number of outputs. Now, combinational circuit can be used or implemented in different areas. So the areas are arithmetic and logic circuit, data transmission circuit, or within code converter. So let us look some example under arithmetic and logic circuit. They are adder, subtractor, comparator, PLDs. Adder is a combinational circuit which adds two binary bits. Subtractor, find the difference between two binary bits. Comparator, compare input and produce corresponding output. And PLDs, under data transmission circuit, there are encoder, decoder, multiplexer, and demultiplexer. Encoder, decoder are used for encoding and decoding data. Multiplexer and demultiplexer are used for sending data in different ways. Under the code converter, there may be BCD to binary, binary to BCD, BCD to gray. There are lots of code converter out there. All these code converter are combinational logic circuit. Now come to the design procedure of combinational logic circuit. Before designing a combinational circuit, you have to follow some steps. So what are these steps? Number one, understand the problem statement. That's mean you are given with a problem to design a combinational circuit. You need to observe the problem very clearly. Next, determine the input and output variable. You have to identify the number of inputs and output required for the given problem. So after reading the problem, you have to identify how many inputs and how many outputs are required for that problem. Now, naming the input and output. At the time of designing combinational circuit, you need to assign or labeling the inputs or output with some letter or symbol as your wish. Suppose a combinational circuit has 3 inputs and 1 output. Then you can name 3 input as A, B, C and the output as Y. Now, after naming or labeling the input and output, you have to draw the truth table. From the truth table, establish the relationship between the output and inputs for all the possible input combination. Then, from the truth table, you have to derive minimized Boolean expression. Since you have a truth table for a functionality, you can derive a Boolean expression from that truth table. For minimizing or simplification, you can use K-map or simple algebraic method. At last, using this Boolean expression, draw the logic diagram. Let us look an example. Suppose this problem is given to you. So now read the problem first. Design a combinational circuit with two inputs which produce output as logic 1 when any one of the input is 0. That's mean if any one of the two inputs becomes 0, the output will generate a logic 1. So you have to understand the problem very clearly. Suppose you have understood the problem. Now what you have to do? You have to determine the number of input variable and output variable. So already it is given in the problem that there are two inputs, and from this line produce output as logic 1. That's mean we are getting a single output over here. So there are two inputs and one output. And then what you have to do? You have to name this input and output. Okay. So the inputs are A and B and output is Y. You can take any name or any variable name as your wish. I have taken A and B for the inputs and Y for the output. Since there are two inputs, there will be 2 to the power 2 or 4 combination of input. Write the output by considering all inputs. So what is given in the problem? If any one of the input is 0, that means if A is 0 or B is 0, the output will become 1. That is, for the first 3 combination of input, you will get 1 in the output. And for the last combination of input, both A, B are 1. That's why it will produce 0. So this is how to draw a truth table. Now what you have to do? You have to derive minimized Boolean expression. And for that, you may use K-map. Now you have to decide whether you required the Boolean expression in SOP or POS. If you want the Boolean expression in the SOP form, SOP means sum of the product, then you have to consider 1 in the output. Or if you want the Boolean expression in the POS form, that is product of sum form, then you have to consider 0 in the truth table. So this is my K-map, 2 variable K-map. Generally we take SOP form. So what we have to do? We will consider 1 in the output. For SOP, consider 1 in the output, and if it is a POS form, then consider 0 in the output. Since I have considered SOP form, sum of the product form, so I will consider only the row whose output
are 1.
Now A has 2 possibilities, 0 and 1. B has also the 2 possibilities, 0 and 1. You can also write A bar in place of 0 and A in place of 1. As you have already seen that 0 can be represented by the negation or the invert of that variable, or 1 is represented as simply writing the variable. So for this 0, you can also write B bar, you can also write B in place of this 1. Now for the first combination where A is 0 and B is 1, that's mean A is 0 and B is 1, that is, it is pointing to the first cell. So what is the output? 1. So just write down 1. For the second combination of input, A is 0 and B is 1. A is 0 and B is 1. That is the second cell. What is the output? 1. Just write down 1. The third combination of input, here A is 1 and B is 0. A is 1 and B is 0. This cell. For this combination of input, output is also 1. So write down 1. And for the last combination, this is 0. You can also write 0 or just leave blank over here. Now, as per the technique of grouping in K-map, so group these two cells and this two vertical cell. So there are two pairs in my K-map. One is the horizontal one marked as red boundary, and the other one is the vertical one which is marked in blue color.
Now from this K-map,
you have to write the expression. Write down like this: y equal to, first take the red marking, this pair. Here A is 0, A is static, and B is changing from 0 to 1. Since it is changing from 0 to 1, so we will not consider B, we will only consider the A only. Since A is 0 in this row, so just write down A bar. Similarly, for the vertical one, here B is 0 and A is changing from 0 to 1. So we will consider only the B variable, not the A. So here B is also 0. So this is another condition. So just write down or B bar. According to the De Morgan's law, if you put the two variable under the same bar, so what will happen? The or will convert it to and both AB will come under the single bar. Now we will draw the logic diagram. So this is the derived expression y equal to a bar plus b bar, or you can also write as a dot b whole bar. So you can draw the logic diagram with y equal to a bar plus b bar as well as with a dot b whole bar. So now let's draw the diagram, logic diagram, with the last expression a dot b whole bar. So what you have to do, you have to first draw the AND gate first, because first AND gate is operated, then it is get inverted. So for the AND gate, draw an AND gate which has two input A, B, and it will produce A dot B. After that, attach a NOT gate and you will get A dot B whole bar. So this is the logic diagram designed to satisfy the given functionality or problem. You can apply the same procedure for larger circuit also. Subscribe to my channel Online Technical Mentor and press the bell icon for latest update. Thank you.